Hi guys, so in a previous video previous lesson we looked at how do we seal up a 5-liter still, the stills that we're going to be using in practical. But in the high reflux distillation section of our grain-based spirits, I'm also going to, the grain-based spirits course, we're also going to be using these stills, and we're going to use this in high reflux configuration in order to show you how do we distill vodka. So many of you watching this, these training or doing these training courses, that's already clients of ours and have already purchased stills, have also purchased these 13-liter stills, and we also get a lot of inquiries about them. So I thought I'd just explain how this works as well, not just in terms of how do I seal it up for the distillation, but also what can I do with this still, because these are powerful little stills. They are by far our most popular stills at the moment, the ones that we sell the most of, because they are so adaptable, because they are so multifunctional, because you can do so much with them. So this is, it might sound like an advertising video, not a lesson, but there's going to be a lot of technical information in here as well. And as I say, any one of you that's doing these courses or doing this training because you want to do product development, if you're going to ask us to recommend a still for product development, this is the still I'm going to recommend for you, because this is the still that allows you to do the most and the most different techniques and the most different setups or configurations of all the stills that we sell. So for product development, this is the most powerful still. It's also a nice size, because a size is a big issue. A lot of guys always say, but how big a still should I buy? And my question is always, how often are you going to distill, and why are you distilling? If you're distilling for home use as a hobby distiller, a bigger still might be a better buy. Something like a 25-liter, maybe even a 50 or 60-liter still would be good for a home distiller to start with, if you're going to be doing it like once a month, because that means in one run you can make 7, 8, 9, 10 bottles or even more if the still is bigger, and you've got your month's supply, depending of course how much you drink. But if you're doing product development, firstly, making big fermentations is expensive. Secondly, if it comes out bad or whatever you tried didn't work, now you're stuck with a whole bunch of bad products, which, well, what are you going to do with it? So a smaller still, not too small, but a smaller still makes for cheaper product development, more effective product development, and you don't waste so much. So as it stands here, this basic configuration, this is the basic 13-liter round still. This is what you buy. Now, as it stands here, if it had anything inside and if it was on the gas burner, this still would be good to go. And you'll notice one big difference from this still, between this still and the 5-liter Limbic, is there is no sealing tape evident anywhere, because you don't need it. All my connection points consist out of a clamp and a seal. Silicone seal, temperature resistant, alcohol resistant, so there's no leaching of chemicals, there's no contamination, nothing that happens inside the still, and it's completely safe to use, and you don't need to worry about working with tape to stop leaks or anything. 100% ready to go. So this is its basic configuration, and this is what we call an alembic still. We've got the boiler, we've got the vapor chamber, and although it might not look like what you've seen in the pictures or in previous lessons, this is the condenser. This is what we call a spirit condenser. Gatling gun cooler design. I'll take it off just now and show you what it looks like on the inside. But this allows me, I can actually show you here on the reflux condenser. It's a larger version, so it'll probably show better on the video. But inside, we've got the tubes for the vapors to pass through, and it's surrounded by water. Cold water in at the bottom, hot water out at the top. So inside here, everything would condense. Obviously here we've got a slightly longer section. At the bottom, we've got the outflow where the distillate comes out, and this little tube over here, that is the surge arrestor. That is to stop what I technically refer to as the glug-glug effect. You turn the bottle upside down, it goes glug-glug, glug-glug, glug-glug. I don't want that. I want a steady, solid liquid flow into my bottle, into my receiver where I'm catching the distillate up in. No mess, no fuss. And again, where it becomes very important to have a surge arrestor is if you connect this to a parrot, which I'll show you just now. But this is the basic configuration. So let's quickly first focus on spirit production, all the different things I can do here with spirit production, and then we'll look at some other things that we can do, including, amongst other things, vacuum distillation, because yes, this still can also be used for vacuum distillation. So as it stands here, as I said, a limbic still, a single distillation, a single run through the still. Now I'm going to take this off, and I'm going to turn this now into a whiskey still. Now remember, reflux, if you think back to distillation overview, the more cycles of evaporation condensation, the more distillations we have, the higher our purity becomes. In a whiskey still, your high vapor chambers, because there's more height, because there's more surface area, we have more reflux, so it comes out stronger out of a whiskey still than it does out of a normal still. And then we also do double and triple distillations, run it through those stills multiple times in order to get to higher purity, between 70 and 80% normally, otherwise sometimes between 80 and 85%, depending on local tradition and legislation. But we want multiple distillations or higher purity distillations in a whiskey run. Now, as it was assembled here, this basic assembly, this is fine for a very aromatic product, like a fruit brandy or a mampur or something like that. But now I want something slightly higher. So I'm going to increase the reflux. And I increase the reflux by adding in a bubble plate and T-section. So my bubble plate goes in here. Now please note, when you use a bubble plate, the downcomer, and obviously now on a small plate like this there is only one downcomer. The bigger the plate, the more downcomers there will be, but the downcomers will always be less than the bubblers. So whatever is the most of, that is the top of the plate. Whatever is the least of is the bottom of the plate. So we put the plate in, rest it on the seal, put the T-section on top of the seal. We attach that to the clamp. And there's no specific way to, or side that the clamp has to be or anything like that. Doesn't really matter. I personally just prefer, for neatness, to have everything out of view. So I always put mine at the back. But whatever side you do put the clamp, just make sure it doesn't interfere with operations. I'll show you later when we use the parrot, for instance. The clamp above the parrot must allow for movement of the actual alcohol meter that floats inside there. Put another seal on, and always remember, everywhere where it's metal to metal, there must be a seal in between, otherwise you're going to get leaks. Put on the vapor chamber. And if it looks a bit wobbly as I'm doing this, please note it's not because of the bad construction or anything. It's just that the stand on which it's standing at the moment is not the most stable of contraptions I've ever put together. Also, because the boiler is empty, there's no weight keeping it stable, there's no weight keeping it down, and that makes it a little bit difficult to work with. Okay, so just make sure that the seal is on straight, because obviously when you do it yourself sometimes then seal can move and then you're not going to get a nice lineup. Okay, so now it's ready for double distillation. So it's going to evaporate, condense, evaporate, and it's not going to condense, there's no plate in there, but it's going to condense along the side, it's going to drip back a little bit. So what I've done now is I've increased the reflux. I've now turned this into a whiskey still. I can expect much higher purity to come out now than it would normally. So that's one configuration, just one. There's many more things that we can do. So I'm going to take this off, take the plate off. And the only reason I'm taking this plate out now to show you the next configuration is for practical reasons for the video. Because for what I'm going to do now, turning this into adjustable reflux column still, I could leave this plate in. And it would make this still even more effective and give me even more reflux. But just for practical reasons, I'm taking the T-section and the bubble plate out just so that you can see the entire configuration on your screen. So, taking off the U-bend. I'm going to put this straight on here. So seal in, head on. Okay, so what I'm going to do now is I'm going to turn this into adjustable reflux column still. Now, you remember the adjustable reflux column stills from distillation overview is where we did distillate flow control. So technically my wording's not right. It will be adjustable reflux, but not based on distillate flow control. It will still be vapor control. It will still be vapor management, coolant flow control. But it's not going to be a fractionating reflux column or plate column still. What we're going to be using is we use an extension pipe. And in this extension pipe, we fill it up with copper mesh. Now the copper mesh is there to, we use it as a packing material. It also removes additional sulfide, so it also gives you more copper contact. So, and it slows down the drip back, if I can call it that, from the reflux extension that we're going to put on top. So this is not empty at the moment, but it would be filled with copper mesh balls that we would put in there. We put that on top. Up. Now here at the top, we add on the bend. Oh, sorry, forgot one part. You can do it just like that, the way I wanted to show you now. All you do by inputting packing in here now is you're increasing the reflux. It's just, again, another version, and a slightly cheaper version than adding in the T section of the bubble plate. But what I want is adjustable reflux. So I add in a main reflux condenser. We've got this small main reflux condenser. This allows us, as with a fractionating reflux column still, to control the vapor purity that comes through by controlling the water flow that runs through this main reflux condenser. And I'll show you more about the water fittings just now, how that works. So we put that on top. And remember how it works. It's like a filter. When maximum water goes through, the holes are, for all intents and purposes, closed. A little bit less water, I can start allowing some compounds to go through. First my volatiles, then my higher alcohols, and my lower alcohols, and finally my tails. So by regulating water flow through here, I can control the purity of what I'm allowing out the other side. And then our final piece, this is where it gets uncomfortable in terms of the height. So hopefully this doesn't fall on my head. You know, I'm just going to take it off here quickly because I'm scared I'm going to knock it off. I'll put it back on just after I've attached that section. Right. And there we go. Now you'll see this is quite, the outflow is now quite high, which is not ideal. So we can do two things. Either we add in an extension, which will obviously bring the outflow lower down, or we can add in a distillation parrot instead of this section over there. Now what the parrot allows us to do, let me just first explain the parrot. We've got our surge arrestor, again to stop the gluk-gluk effect. The distillate flows down, flows up, and it rises up in this piece over here. Then it flows over into this catchment, and then it flows out. And at the bottom we've got a drain valve. Now the reason for the parrot is that in here floats my alcohol meter. So I can get a real-time reading, how strong is the alcohol coming out of my still right now. This is very important when you're using a main reflux condenser, because using that main reflux condenser, I can control the purity. So this alcohol meter reading tells me should I put more water through or should I put less water through my main reflux condenser. This is what tells me how to control my still, what I need to do in order to control the still. This is what I use the parrot for. The drain valve at the bottom is so that you can drain whatever's left in the parrot at the end of your run. But in the beginning as well, this is where we take the heads off before we start filling up the parrot. Because what you don't want to do is you don't want to contaminate the parrot with heads. Because keep in mind now, it flows down, it fills up the parrot and then flows over. So let's say the last little bit of heads comes through here. I now have to get enough alcohol in here, hearts in here, to displace that last bit of heads as well. So now I've contaminated all that alcohol used to displace the last bit of heads. That's wasteful. So we take the heads off at the bottom. Once the heads is done, now we close it, now it fills up, and now we start doing our hearts run and controlling our adjustable reflux while doing that hearts run. So that's what we use the parrot for. Now, let's say we want to go a bit fancier. A bit more reflux, but get a bit more purity out and run it a little bit easier and make it aesthetically more pleasing. Then we replace this adjustable reflux section or this packing column with an actual plate column. Now this is a 4-plate glass column. It's got 4 little bubble plates in there, much smaller obviously than this 4-inch one, but the principle remains the same. And it also has a main reflux condenser. So now I've got once distilled, and this thing will go here. I'll show you an assembled one just now. So distilled once, twice, 3, 4, 5 times distilled, plus whatever reflux I put in here as well. And when assembled, it looks like this. Now here you can also see the parrot mounted, because again in this configuration the parrot would be very important so that we can actually measure the alcohol percentage. You'll also see at the top here we have a thermowell and with a thermometer. That can be assembled on the packed column as well. And the reason for this, now we've spoken about this many times, you can't distill at a temperature except within specific parameters. Within a specific frame of reference, yes, you can distill according to temperature, according to changing temperature, but according to temperature. And that specific parameters applies to the temperature post-reflux, after the main reflux condenser. If I control that temperature, not this one will climb the whole time. This one will continuously change. But this temperature up here, if I control that temperature by controlling my vapor, my coolant flow through my main reflux condenser, I can control the purity that comes out here. For instance, in our location here, if I keep that temperature up there at 68.3 degrees Celsius, I get 95.6% alcohol coming out of my parrot. That's what we use that thermometer for. It's another level of control. It's a faster level of control, because if you're just going according to the alcohol percentage here, by the time that vapor comes through and it's been displaced, and you see the change happening here, you've already sent a lot of alcohol through the system. So it might not be at the ideal percentage, it might be too low, it might be too high. By controlling according to that temperature there, not by controlling the rate of heat addition, but by controlling the coolant flow through the main reflux condenser. By controlling that coolant flow, I can control that temperature, and that will impact my alcohol purity or my alcohol percentage coming out of my parrot. So much higher purity can be achieved with this, faster than in a packed column configuration. Some other configurations that we can use. If we're going to start taking this or disassembling this again, I can, for instance, completely do away with the alembic head. I don't have to use the alembic head on this at all. By taking the alembic head off, I can put on my T-section with my bubble plate, and I can put a couple of them on. Maybe I wouldn't put more than 4. It's not a big enough boiler to validate more than 4, but even 2 will be enough. And on top of that, we put our main reflux condenser, our 4-inch main reflux condenser. You will then need a reducer to allow you to still use the U-bend and the spirit condenser, which would then go on here. If you have a reducer going to there, you could use it in that configuration as well. Another possible configuration, and this is now going beyond the realm of normal distillation, or just normal spirit distillation, is if you wanted to do gin. Now, this is a botanical extension, ginning head, whatever you want to call it. So quite a big one actually. So you could actually use this as a essential oil extension as well. So we put that on with our head, and I'm not going to put the clamps on now. You've now seen our clamps work. And we add on our U-bend and spirit condenser, and voila. Now I can make gin. So I put my botanicals in here, put my alcohol at the bottom, and I do my vapor infusion through my botanicals. If I was doing an essential oil extraction, I put a lot more botanicals in. I put water at the bottom or whatever I'm using to do the extraction with, and I just distill that through, et voila. Just keep in mind, if you're going to use the same still for alcohol and essential oil, you really need to clean it really, really well with both caustic and acid after the essential oil run to get rid of all those oils. Probably need to wash it with a dishwashing liquid as well. Now, another version of the ginning head would be to use just a straight. Not necessarily use this, although that looks beautiful and it's also very cool to see what's happening inside, but you can just use a stainless steel extension. Now, this is a very tall one. This is specifically for botanicals. This is not, this is way too big for ginning on a still of this size. But if you wanted to use it for essential oils and you didn't want to spend the money on that type of unit, you could just do it like this. And there you have an essential oil still. And this would also work just to increase the reflux. Again, turning it into a whiskey still. This is cheaper than buying a T-section with a bubble plate. And you can still fill this with copper mesh as well. With this, you would get a sieve similar to that one that goes at the bottom to stop the botanicals from falling through, or if you're putting copper mesh in there to stop the copper mesh from falling through. So again, multi-purpose. And this section can obviously come in different lengths. You can have a short 10 centimeter 120. This is a 30 centimeter or 300 millimeter extension. Many ways you can assemble that as well. Now, in terms of water connections, you would see that both on the spirit condenser as well as on the main reflux condenser, we've got pneumatic connecting valves. Now, these pneumatic connectors are not just fitted onto the sections or on the condensers. We have a variety of them. And so you can basically plumb this any way you want to. So the basic connector looks like that. And this is what we screw into the connectors on the actual condensers. The way to use it, you just put it in, and there you go. It's easy as that. Literally just plug it in, and it's sealed. To release, you pull the blue lever back, and you just pull it out. That's how easy it is. No mess, no fuss. The piping comes in both obviously blue and red. So for cold water, blue, or outflowing water or hot water, you use the red piping. So traditionally, you would have one pipe coming in, one cold water pipe coming in, one hot water pipe going out. And that's fine if you're just using the spirit condenser. You'll have cold coming in the bottom. Remember, water flow always opposite from vapor flow. So cold coming in the bottom, rises up, hot going out the top. If, however, you are using the main reflux condenser as well, now you've got two water flows that you need. Now, you can, if you want to, run it from two separate taps and two separate pipes coming in. you can do that. But alternatively, you just use a T-section, where you split it into different directions. The other thing you will definitely need as well, oh, and then you've got, sorry, Y connector, not T connector. There's your T connector. So you can use the T connectors to obviously put all your outflow pipes coming into one outflow pipe and split your incoming water flow into different pipes as well. You will also need, specifically for the main reflux condenser, you will need a needle valve connector. The needle valve is to control your flow. Now please note, these are not omnidirectional. They have one specific flow direction, so which is indicated in a very hieroglyphic manner on the controllers. Hence, the ones that we sell, we always, with a white marker, we do mark the flow direction on the valve so that you use it correctly. So in, out, and there's my flow control. It gives you very, very fine control, and that's how you control your water flow going through the main reflux condenser. Then there's obviously elbows. There's elbows that can connect to normal household piping and so forth. So depending on how you're going to connect your water, the connectors you need are available, and they all work the same way, just plug and release. That's how we connect the water on these stills. There's not much more I can show you about this. There's much more that you can do. I am just going to go grab a vacuum pump quickly to show you how we set this up as a vacuum still. Right, so here we now have the 13-liter round still in vacuum configuration. Now please note, in terms of the actual still, everything I showed you beforehand in terms of ginning sections and the fractionating column extension and the packing extension, I can still do all of that on this side. The only difference with the vacuum part comes in here. Obviously, you can't use the parrot. You can't use a parrot in vacuum configuration. Well, at least not with this still. There are vacuum stills where you can use a parrot, but they're completely different design. So in terms of the vapor path, I can play around and do anything. So I can do vacuum extraction of essential oils. I can do vacuum ginning. I can do vacuum distilling. I can vacuum anything I want. So the way this works, obviously the surge arrestor will be closed off. We put a cap over it to make sure there's no air being pulled in. We then connect the outflow tube, gets connected to a capture flask or vacuum flask. Now this would not stand up here, it would be down lower, but for the video purposes I just raised it up so you can see it. And then the vacuum flask is connected to a water circulation vacuum pump. Now it is this pump that pulls vacuum through the flask, through the piping, through the actual still. And this still can handle it. It can handle the vacuums generated by this pump. And you don't have to go for full vacuum. Even if you're just looking for lower air pressure to drop down the boiling temperatures, that would be useful. And then we've got our release valve here to release vacuum when we need. So the distillate, or I'll put my fermentation in the case of a distillation, I'll put my fermentation in here. It will boil now at a much lower temperature than normal. It will rise up, it will go through, it can condense into a liquid. The liquid will run into the flask, which, as I said, would stand at a lower level, and all the alcohol will be captured in here. If you are pulling full vacuum or a very, very low vacuum, then obviously ambient air pressure might be, or ambient air temperature might be enough to already turn this liquid back into a gas. Then you would have to create a cold trap where you put this flask inside an ice bath or dry ice bath or something to keep it as cold as possible to make sure that the distillate stays in a liquid format. Now you might think, but why on earth would I want to do this? What's the point of the vacuum distillation process? And especially in product development, why would this even make sense? Now, vacuum distillation, we're going to talk about vacuum distillation quite a bit in our botanical or infused spirits training when we look at gin and botanicals. There is a section about, or a discussion about vacuum distilling in that course as well. But the main thing is that vacuum distilling on a commercial scale, in order to make, for instance, vodka, is not really worth it. There are very few vacuum distilleries in the world. Here in South Africa, Durbanville Distillery is the only vacuum distillery in South Africa, and I think when they opened, I'm not sure what the current figures are, but when they opened, they were one of only 7 in the world doing vacuum distillation for potable alcohol consumption. it is an extremely expensive process. The equipment is very, very expensive and not readily available. In the case of Durbanville Distillery, the owners, their father and the son team, they actually designed their own, built their own equipment. They're both engineers, so they designed and built their own equipment. They even had to write a computer program to run the still, because a normal person cannot run a vacuum still. There's too many variables involved, so to run it is extremely difficult. It's expensive. Some people incorrectly assume that vacuum distilling would be cheaper because I don't need so much heat energy in order to bring it to a boil. And that's true. I mean, the first test we did when we first got one of these units and we tested it, we just did with water. And the water was boiling at 28, 29 degrees Celsius. The water was boiling. I lifted this up. I lifted the still up, holding it in my hands as it boiled. It was the weirdest thing ever. It's very cool, but the problem is that people see that and they assume, but okay, it's going to be cheaper to run the still because I'm using less heat energy, I'm using less electricity, less gas, so it's cheaper to produce the alcohol. But that is not the case. On a commercial scale, you need to take two other things in consideration as well. Firstly, the energy usage of the actual vacuum pump. And secondly, the energy usage and the cost of your cooling plant. Because now you have to, in some cases, keep your condensers at like -4. Now you're looking at glycol chillers and so forth. You're looking, and now it's not just the spirit condenser that gets cooled. Everything, your holding tank, your parrot, everything needs to be cooled, because the holding tank in which the distillate flows is also under vacuum. Otherwise you can't run the vacuum still. So the cooling cost is immense to do vacuum distilling. So no, not really commercially viable. It doesn't really make sense. There are arguments to make for quality, but the question you have to ask yourself is the quality difference so big that the consumer would actually pay more, because they will have to pay more for this vacuum distilled product as to a normal distilled product. Because yes, you can make the argument, I can capitalize on vacuum distilling as a marketing thing and make that part of my story, and then people will pay more because of the uniqueness of the fact that it's vacuum distilled. But the problem is most people don't understand it. The average consumer does not have the technical appreciation for what a vacuum distillery does and what they accomplish. We do. We as distillers, we who know what's actually happening here and know what the challenges they face, we appreciate it. But the average consumer does not appreciate it. They don't understand it. So from a marketing perspective, also debatable whether it's actually going to help you or not. So why then do I even mention it? Because vacuum distilling has one very, very, very important practical application, and that is with gin. In the ginning course, the infused spirits course, we will be talking especially about thermosensitive botanicals. Now, thermosensitive botanicals are botanicals that changes, where the flavor and aroma changes with the application of heat. So if you're doing infused distillation or vapor infusion, where heat is being applied during the infusion process, you're not going to get that fresh, nice taste out on the other side that you actually wanted to. A perfect example would be, for instance, cucumber. When we first started doing distillation training, or actually when I personally started doing ginning training, the flavor of the day, or the gin of the day back then, was Hendrix. Everybody wanted to emulate Hendrix, and Hendrix, the main thing being obviously the cucumber flavor that you find in Hendrix. So everybody wanted to infuse cucumber. The problem comes in when you're doing infused distillation or vapor infusion with cucumber. What comes out is boiled cucumber. Now, I've not known if any of you have ever had boiled cucumber. It's not very nice. It's not very appetizing. So not really a flavor or aroma that you want in your gin. But do that under vacuum condition, and you're doing vapor infusion. Now the temperature of that vapor passing through that cucumber is basically ambient. It's 25, 30, 35 degrees. That's not hot enough to change the characteristics of the cucumber aroma and flavor. So now you can get that fresh, crisp cucumber flavor in your gin. And that's just one example. There are many, many examples of botanicals where the flavor and aroma changes with the application of heat. So vacuum distillation on a small scale like this, or let's call it what it is, vacuum infusion on a small scale like this, allows a small craft gin producer to experiment and see which of my botanicals might benefit from a vacuum infusion. If you identify that a botanical will benefit from vacuum infusion, then you make a concentrate basically of that one botanical on a small scale in this actual still. I mean, if you're not going to use a lot of that flavor in your total gin blend, then you can make, in a small 13 liter like this, you can make a vacuum concentrate, vacuum infused concentrate, which you then blend in with the rest of the gin that you made normally in a normal still. So you don't need to convert your entire distillery or your entire big gin still to vacuum. Just do it on small scale and then blend back in. So you can still get the benefit of vacuum infusion on that one botanical where it is relevant, but you're not needing to change your entire production process. So if you are doing gin product development, it is something that you might want to consider to see, is there any of my botanicals that would benefit from vacuum or not? But that is now the last configuration that we have for the 13 liter still. So I hope you have a better understanding now how this still works, how it can work, and all the different ways that we can actually assemble and configure this unit.